We are now going to do indicator 4. And indicator 4, my learning target, I can write and evaluate numerical expressions involving whole number exponents. So we're going to be working completely with exponents over here. There are certain vocabulary words that are required for exponents, but what exactly is an exponent? All right. So the exponent of a number says how many times to use the number in multiplication. So that's basically what an exponent is. All right. We are going to go ahead and talk about all these vocabulary words which are related to exponents. As you can see, base, exponent, exponential notation, expanded form, standard form, power index, squared, and cubed. So these are different things that you have got to know that belong to an exponential notation or exponent lesson. Okay, so if I say base, and if I write let me get a different color. Okay, so if I write 2 to the 5th power, my 2 is my base number. My 2 is my base number. And then my exponent is the 5. This is my exponent. Okay, so 2 is my base, 5 is my exponent. And when it's written in this format, like we've written, 2 is to the 5th power, when it's written like this, it is called exponential notation. All right, now, another term, I just want to show this to you because it goes hand in hand. If I'm saying power or if I'm saying index, that also means exponent, because you could have written 2 to the 5th power. Okay, so these are also words which describe an exponent. So you can see this is an exponent, the 5 over here, also written as power or index. So this all means the same thing. Okay, now expanded form is, please do not write 2 times 5 because I do see children rushing and doing that. That would be something totally different and it would be absolutely incorrect. So expanded form, what an exponent actually means, you are taking the base number and multiplying itself how many times the exponent is saying. So if I say 2 to the 5th power, the expanded form would be this. My base number is 2, and I would multiply 2 with itself 5 times. So look, 1, 2, 3, 4, 5. So that's what 2 to the 5th power means. Okay, and now when I convert this to a standard form, all I'm doing is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, and 16 times 2 is equal to 32. So 32 is my standard form. When I have multiplied 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So expanded form is written out like this, and the actual answer is written out like this, as 32. Okay, now squared basically means anything to the 2nd power, but we don't say 2nd power normally, we say squared. Okay, so if I write 5 squared, is written like this. That means 5 times 5, which will give me 25. Okay, so this is what squared means. Okay, the 2nd power. So if I was going to put this into expanded form, it would be 5 times 5. And then when I solve it, to give me the standard form. This is expanded form, and the standard form would be 25. Okay? Cubed means any base raised to the third power. So if I write 5 cubed, so this 3 actually means the exponent of 3 means cubed. Okay, and we don't write 5 to the third power. We don't normally say that. We say 5 cubed. Okay, so if I was converting this to expanded form, I would do 5 times 5 times 5, not 5 times 3. So 5 times 5 times 5. And when I multiply 5 times 5, I get 25. 25 times 5, and I get 125 as my standard form. So this is how we basically solve problems with exponents. And the easiest ones to solve are numbers where I may have, let's say, 10 to the 6th power. Okay, so basically all this means, if I'm doing expanded form in order to solve this one, basically it's 10 times 10 times 10 times 10 times 10 times 10. So I've written the 10 6 times, 1, 2, 3, 4, 5, 6. So if I was ever converting something, and this 10 to the 6th power, 10 to something power is always used in scientific notation, which we'll talk about later. But it is really simple. If I'm saying 10 to the 6th power, basically it means that it is 1 followed by 6 zeros. Okay, so if I do 10 to the 6th power, it means this. So 1 million. All right, so it becomes really, really easy. This is one of the easiest things to calculate when my base is 10 and then I'm given a certain power. If it's 8, I will have 8 zeros. If I have 5, I will have 5 zeros. So this is one of the simplest things where exponents are concerned. And that is why in exponents we have numbers written out like this, because it really helps to simplify multiplication. Okay, exponents make it easier to write and use many multiplications. So that's what this is. Okay, I'm going to go ahead and show you how you can solve problems relating to this. Of course, you've got to know your order of operations. Please remember with order of operations the PEMDAS, which you have done in the past. So let me erase over here. And please remember PEMDAS from the past, okay, where my P stands for parentheses, E stands for exponent, M multiplication, D division, A addition, S subtraction. So parentheses is always done first. Next is exponent. If I have only multiplication and division left, then I do from left to right. Okay, then I do from left to right. And same thing if I have only addition and subtraction left, I will do this from left to right. So these are certain rules. Please remember what PEMDAS stands for. You have got to follow that order of operation when performing any math, solving any math problem, so that we don't make any mistakes. Okay, so let's say my question is, if I give you b squared plus 8 and I say b is equal to 5. Okay, if I was to solve this, so b squared plus 8, so based on order of operations, what we're going to do is that we are going to do the exponent before the addition. Please don't do it the other way around. Okay. So if I've been given that b is equal to 5, I just take this value and substitute it over here. So this actually means 5 squared plus 8. 5 squared plus 8. Okay. Once again, please don't do 5 plus 8 first, because that is incorrect where order of operations is concerned. You have got to do the exponent before addition based on what I just showed you. Okay. So 5, and again, it's not 5 times 2. That is a common mistake when you are rushing. It means the base number multiplied by itself however many times. So 5 squared actually means 5 times 5. That's what this means. Plus 8. So 5 squared is 25 plus 8, which is going to give me 33 as my answer. Okay, so let's do another problem. And let's say I give you 8 cubed minus 8 cubed minus 9. Okay, so 8 cubed basically means 8 times 8 times 8. So you are multiplying 8 by itself 3 times. Okay, that means 8 times 8 times 8. Okay, minus 9. Okay, 8 times 8 is 64. 64 times 8 gives me 512 minus 9. So this is the order that I'm solving in. And remember, the exponent comes before the subtraction. Okay, so if I subtract 9 from 512, I end up with 503 as my final answer. Okay, so let's do one last one before I show you a little bit more advanced stuff. So this, if I say, let me just erase this. Okay, so 25 squared minus 12 squared. If I give this to you, please remember the vocabularies. When I'm saying squared, it means it's raised to the second power, but we say squared. Okay, so this means 25 times 25, not 25 times 2. Okay, so 25 times 25 minus 12 times 12. That's what this means. Okay, so 25 times 25 is 625 minus 12 times 12 is 144. And now I just subtract, and I'm going to get 481 as my final answer. Okay, so this is how we solve problems revolving around exponents. Because you are an accelerated class, always like to teach my kids a little bit more than the required amount. So let me show you some problems where we have a negative exponent. Okay, so negative exponent. And let me just give you a problem. Let's say I give you 8 negative 1. So these are negative exponents. Again, this is something going beyond what our standard is, but I always like to teach the kids a little bit higher so that, later on you find this concept a lot easier. This is just an introduction, okay? So negative exponents. So if I had said 8 negative 1, So in this case, I know that if I had anything to the first power, it would be the number itself. If I had just said 8 to the first power, it would actually be 8. Okay? But, and I know if I said 8 squared, it would be 8 times 8, and I would get 64. And so like, this way we carry on. Now, if I have 8 negative 1, all I do is I just take the 8 and it becomes the denominator. So if I'm saying negative 1, that is 1 times, it'll just become, you just flip it like this and you do 1/8. Okay, so that's what your answer will become. It becomes a fraction form where whatever your base is, it becomes the denominator. So you would write 1/8, and later on when we are doing division by decimals, we'll get more into dividing a number which is a smaller numerator than a larger denominator. But if I was dividing this, I would get 125 thousandths as my standard form. Okay, if I said again another negative 1, I'm just going to give you an example. Please remember, this is just extra information, the negative exponents. So if I said 5 negative cubed, I would basically write this out as 1/5 times 5 times 5. All right, so this would be equaling 1/5 times 5 is 25, times 5 is 125. And then when I simplify dividing 1 by this number, again, this is going to be the next unit. Okay, so this becomes 8,000th as my standard form. Okay, so I just wanted to show this to you as to what happens when there's a negative exponent. There's no reason to like, oh gosh, what is that? All it happens is that the base actually becomes the denominator and you write 1 on the top. Okay, so this is just an extra thing that I pushed out at you. So anyway, exponents, that's what indicator 4 is. Mostly it's only positive exponents that we have to work with right now. You're evaluating numerical expressions involving whole number exponents. So when I say that, that means all those problems that I had given you, like 25 squared minus 12 squared. So that is what that learning target is about. You've got to know what the vocabulary words are. And exponents definitely make our life a lot easier because it is simple to write the big numbers out in the exponential form rather than writing the expanded form, which is like humongous. All right. Have a nice day, guys.